Hello again. It's nice to be back at the DKNOG and good to have a Dutch hour, so to say. So my name is Melchior. I'm part of the service provider architecture team in Juniper, and I don't have a clicker. It's here. So I work a lot with our SP customers on helping them evolve their networks. And the topic of today I found I wanted to share something about is how to scale out edge services. So stuff like CGNAT, carrier grade net, but also IPsec, etc. Some of the stuff I might talk about is not in our products, might not show up in our products, etc. So basically this whole text says don't buy anything based on what I'm telling you today. Hey, that's easy, right? So as we all know, the internet is still growing, right? It's not growing as fast anymore as it did, but we still see new users and new devices being connected to the internet basically on a daily basis, which means that it's a variation of mobile users, of IoT devices, of rural areas getting connected. And obviously by that, the need for IP addresses is still growing. And as probably a lot of you know and are aware of, the registries have sort of run out of IPv4. The market is also a bit declining, so it's harder to get IPv4 space in order to accommodate for all these services. Well, in the meantime, a lot of the equipment still being used by operators on the internet is still not capable of doing IPv6, or there's other reasons for not deploying IPv6. So we're still, let's say, stuck with IPv4 for quite some time. As you can see here, IPv6 is uptaking, but it's still not even half of the traffic Google is seeing is coming from an IPv6 address. In other words, the other half of the internet basically is still relying on IPv4. So we are out of IP addresses, right? Out of IPv4. That's probably old news. So the problem is, as probably a lot of you are aware, you still need connectivity to IPv4, right? Even if you have your subscribers on net solutions, IPv6. In the data center, we heard this morning from a colleague from Cisco that IPv6 is used in a lot of SR deployments in data centers with cloud providers, etc. But still, v4 needs connectivity. And a lot of devices are simply not capable yet of doing v6, right? Even devices which are now being sold, IoT devices, etc. A lot of them don't have are not IPv6 capable. Sorry? Oh, I thought I heard a comment. Basically the problem is IPv4 is not expensive enough for those to replace equipment with IPv6 capable equipment or make the necessary changes to OSS, BSS systems, etc. And the price of IPv4 is, I think, already slightly decreasing a little bit as well. So, sorry? Yeah, exactly. Quite a lot. Right, exactly. So what's the business reason for switching to v6, right? That is basically the whole problem. And there's also indeed some technical challenges to solutions which are currently in use, right? We all know the big chassis and racks full of equipment. And for years, we as network vendors, as industry, have been used and built products with more and more ASICs in it. And ASICs do a great job, right? ASICs are really good in forwarding. You cannot find anything which is faster in doing packet forwarding than an ASIC. However, if you look at services, for example, again, indeed CGNAT, IPsec, etc., x86 is much more powerful in doing so, and especially the newer CPUs which are coming out now, the new Intel and AMD CPUs are really powerful, right? I'll show some data on that. It's amazing how much you can do with x86 in a 1 or 2U server if you compare it to services cards in a router. And obviously, because the footprint is much lower of a server, both in energy consumption, but also the capacity to physical size ratio is much better. So you need less space, less power, etc. So basically scale up has limitations, to how much you can fit in a single rack, right? Scale up, we saw in the data center already with IPclo and some of the larger operators are even building scale out routers with 1 or 2 U boxes instead of very big chassis. And that's something we see happening now in services as well. So one of the services specifically interesting, coming back to the IPv4, IPv6 discussion, is obviously all the various CGNAT solutions, right? Something which is used a lot by SPs is DS Lite. For those who are not familiar, DS Lite is basically tunneling traffic, IPv4 traffic over IPv6 and does a conversion on the internet suppliers or internet providers router. So you basically strip off the IPv6 header and then do a net translation from v4 to v6. Huge deployments in use currently today, but a lot of them are indeed chassis-based solutions with services cards. Some providers are, let's say, deaggregating or bringing these services further out to the edge because of scalability issues. However, a lot of the telco data centers are not really meant for having so much active devices, right? And again, chassis are relatively big, whereas other SPs are bringing them to more central locations, so they need even more chassis in the same place to do these kind of CGNAT solutions in order to accommodate their customers. So for those not familiar, scale up simply just putting in a bigger chassis, and scale out is using multiple chassis or multiple smaller boxes to achieve the same thing. Right, again, as we saw in the data center, IP fabrics is the perfect example of scaling out. And basically the idea, what we have with scale out solutions for services is that you still have this router, but instead of trying to do everything on the router, and try to do everything in ASICs, we're now attaching or scaling that out with x86 hardware. It's in different forms, different solutions from different vendors. So why are we doing this? Basically because cloud has proven that you can much more easily, faster deploy these services, right? It's easier to spin up a new VM or container on a server than to reprogram an ASIC. And in some cases, ASICs are very strict in what they can do, and they do that again really well. I don't want to disqualify ASICs, but it's harder to, in many cases, deploy new services on an ASIC-based system, right? So. And we're seeing that a lot of service providers are now embracing cloud as well, whereas a couple of years ago, everybody was still very much used to running stuff on-prem, preferably in hardware. You now see with many service providers is that they're deploying larger clouds on-prem with Outpost or OCI or other solutions, and start to get used to the idea of using those clouds to host SP edge services. And there are some other business drivers and interesting things as well. Next to scalability, it's obviously easier to scale, and you can work with flexible licensing models and stuff like that. So also a lot of again, SPs are now embracing that cloud native, so to say. So what's the advantage of VNFs? I think the majority of people know in this room. But again, basically being able to scale out, it's easier to separate customers in VMs, right? And if you need, or spread them out, if you need additional capacity, you spin up another VM, and you can spread the load over those VMs, so it gives you a lot of agility, etc. Again, that doesn't. I mean, you can do a lot of forwarding on x86 as well, but for very large traffic volumes, you still get much more performance out of ASIC. So what you see is that we're trying to, let's say, separate those functions. So what is it I'm talking about? Scale out services architectures. Basically, you still have your router, and next to that you have one or multiple x86 servers running a hypervisor and VMs or containers. What you see now is multiple vendors coming out with tools to manage that, whether that's on the router to deploy these VNFs or with orchestration and containers. And there's multiple ways how you can route the traffic. So we'll take a quick look at how that works, and we call it data plane integration. So basically, what you do, the traffic comes in from your customer in, for example, a CGNAT DS Lite scenario. Subscriber traffic comes in on the router in a VRF. You route that using BGP, or could even be static routes or whatever, to one or multiple of these VMs. The VM works as the AFTR, so it basically does the decapsulation of the traffic and does the net functionality and sends the traffic back to another VRF or routing instance towards the internet, and the other way around. And as you can imagine, this scales much easier than having to put in another line card in your router, or if it's full, add another chassis or upgrade the chassis, etc. There's a lot of considerations here because you need to take into account some of the let's say properties of the servers and especially the CPUs, because you have the NUMA boundaries, and VNFs tend to, if you go over the NUMA boundary, tend to take a performance impact. But if you do this a bit wisely, in the example here you see 100 gig interfaces, for example, per VM. And I'll get to an example of a server we did a proof of concept with one dedicated 100 gig VM interface per VM. That was the optimal in that case. But so this is still a lot of trial and error, so to say, but a lot of the vendors, including the server and CPU vendors, are very interested in testing with customers on specific scenarios. So this is one example. This is the most easy one, right? You just have a router, and on the VNF you configure one or multiple routing instances. In this case, you have two routing instances, one where the traffic comes in, as I just explained, from the customer, and the other one is basically the outgoing routing instance. And you use IFLs for routing, firewall filters to separate the traffic, etc. This is the most easy, so to say, to implement. This would work perfectly if you have a small setup. If you have one, let's say, customer type, and you need to just send all the customer traffic to via this service. It scales pretty well, but the disadvantages are that it's quite a lot of manual labor, right? You need to configure the IFLs, IRBs, VLANs, static routes, etc. Perhaps nicer implementation would be to use multi-protocol BGP. So basically you configure per customer a VRF, and the customer could also be in a multi-tenancy environment, different customers or different, let's say, types of customers, right? Different services depending on what you want to offer per customer. So in this case, we run multi-protocol BGP. You obviously need MPLS support. That is the downside of the solution, because not every VNF or every device might support MPLS. And the advantages are you need much less manual configuration, obviously. Once you've set it up, you route all your traffic via that VNF. But yeah, so it's a trade-off. You need to have MPLS knowledge in this case. But it scales really well. The limitations are that all traffic in this case is using the same IFL and security zone. So you need to make sure that your filtering in the security zone in this case is obviously in order, because otherwise you might be able to leak traffic between customers. So again, this is something which it scales nicer, but but you need to think about it a little bit more. So how does it work from a VNF perspective? You basically announce, in this case we have 3 VNFs with 2 different VRFs per VNF, all those 3-letter acronyms. So from the VNF you advertise, from the VRF you advertise the specific route. In this case we use ECMP equal cost multipath load balancing in order to load balance the traffic over the VNF. So you basically, the configuration from a VNF perspective is basically the same for each VNF. So you advertise a specific route towards the router, and based on based on filters. So I need glasses, I think, based on, or I need a bigger type. So you use filter-based forwarding to take the sources. In this case, we have two subnets from customers, 140/8 and 141/8, and you route the traffic from the customer using filter-based forwarding towards that, so to say, anycast IP address. And you basically load balance the traffic over the different VRFs. The other way around, in order to make sure the traffic comes back, you obviously need some source-based filtering as well, because by nature, obviously, you want to keep the traffic on the same VNF. But the other way around, you announce the specific customer route from the client VNF to the router in the middle, and that one announces it to the VNF. So it's in that sense pretty straightforward. If you obviously want to scale this much larger, you might want to think about doing some controllers and stuff, because this is nice if you want to configure it for such a simple setup. But imagine if you scale this bigger, you still need a lot of work to be done there. So speaking about the proof of concept I mentioned, what we've done is, in this case, we've tested with AMD CPUs, the 96 cores. There are newer CPUs now. I think they're about to come out, or they're already out, but this was a test we did a couple of months ago. The reason for taking a 2U server is simply because we could not fit enough 100 gig interfaces in a 1U server. And coming back to that comment about the NUMA domains, what we did is in our case, it's called VSRX, which is the virtual firewall. So we spun it up, gave it 31 virtual cores each. So you could have 3 of these VNFs per core, per socket. And so meaning that you have 6 of these VNFs running in 2U. You need obviously an enormous amount of memory in the box, and as you can see, interfaces. So in total, 6 interface cards with each dual port, meaning you have 100 gig 2 times dedicated per VNF, and we couldn't fit that in a single box. So if there's a vendor who has a single box, then you can even go smaller. The result of that is, after doing a lot of tests, and you can see here, this is a very specific case, very specific IMIX size, and with all security services, it totally depends on your traffic mix and which services you enable. But specifically for DS Lite, per VNF with this 31 vCPUs and 96 gigs of memory, we reached a little over 80 gigabits of traffic per VNF. So if you do that 6 times, you now have in a 2U server close to 500 gigabits of DS Lite traffic, which you will never be able to do in ASICs, right? If you would compare this to chassis, I don't have the exact number, but I mean, even within a rack, you would probably not be able to fit so much DS Lite traffic. So it's a really nice use case how you can now deploy these DS Lite services on a much smaller footprint. And that was it. Any questions? Oh, 2 mics standing up.
I'll go there first. Hello, this is Wilhelm. Thanks for an interesting talk. I was a bit curious in VSRX. Could you share a bit about what's under the hood? I imagine it's DK somewhere down there.
Yeah, you obviously need in this case direct access to the NICs because you cannot get that performance if you don't have that. So that's why indeed we have direct link between the interface and the VNF. You could do this with 400 gig uplinks, right, and then split it out, etc. But then you don't get the performance. So that's why we have the 100 gigs dedicated. And your question also reminded me of something which is also interesting. If you look at previously, a lot of the physical firewalls would have ASICs in it as well. Now you see a trend with different vendors that they're all switching for firewalls to x86 again, right? Because of they're much more powerful. But yeah, to come back to your question, there's direct relation. Yeah, definitely.
Anyone else? Any other questions? So we have time, huh? It's like 17
We can also
minutes.
talk about quantum. That's what we did last year. That's my other favorite topic. So
Can switch topics. No?
all right.
Okay, then
Thank
let
you.
me get some chocolate for you
Ooh, nice.
down here.
Is it chocolate from Switzerland?
No, it's not. That one.
You have to win the quiz.
Ah, thanks.